So, about veterinary medicine 101, let's go to lab work 101. So, as I've discussed previously, when you go to the vet for an emergency or a sick animal, or even your annual blood work, the vet's going to come back in the room or call you the next day and tell you what all is abnormal or wrong or elevated or low or whatever that's not right or not normal on the blood work. And we're going to do a whole series of videos about each individual one of those items and what they mean about organ function and health. But before we do that, we need to know, where does the normal values come from? What is normal? How do we know what's normal? And where are we getting this information that we're comparing to that we use to determine if something is wrong or abnormal or sick? So, basic explanation is this: whether it's 80 or 100 years ago or whenever, scientists and researchers started finding all these things in the blood, all these enzymes and all the stuff that we measure on the blood work. And they started finding, okay, this is what it is, and this is what it does or indicate, but they don't know what normal necessarily is. So they measure the value in dozens of people or dozens of animals, and then hundreds, and then thousands over time. And over time, statistics starts to come into play that out of all these apparently healthy individuals who's measured, this number always comes back within a certain range. This is a bell-shaped curve. That's what we're looking at now, is why it's called bell-shaped, is because of this picture. But what this bell-shaped curve means from a statistical point of view is that all of the numbers are going to be around the average in the middle. That's the peak of the curve. And then 68% or 63% or whatever the number is of those are going to be within a certain distance from the middle. So, for an example, let's use blood glucose. That's your blood sugar. That's what determines diabetes. So, let's say normal is supposed to be 80, and you measure that in 100 individuals, dogs or cats or people. Well, 80 is going to be the middle peak of the curve. That's the average. That's where the numbers all average out to. But within this distance away from that 80 is where this percentage of them, 63 or 68%, are going to be. They're going to be between 75 and 85. And then this next branch over that you can see here gets you up to 95%, or 95 out of 100 samples we tested are going to be within this range. They're going to be this far away from the 80. And that gives you basically a reference range. That's what you see here on the printed out lab work. The reference range is going to be between, for example, these are just examples, 70 to 90 is the reference range and 80 is the average. So in theory, if your blood sugars are between 70 and 90, you're considered normal or within normal limits, WNL, and that's what the reference range is on the blood work. So that's how that's determined. So that's fine. There's two little problems with that. One is these averages change over time as they keep measuring blood work on millions of animals. There's two big main labs in the country that all vets use, and they're measuring everybody's blood work. So they've got millions of data samples. Well, over time, just like people, the blood sugar example is a perfect one for this. Our sugar is going up and up and up over time because we're eating more and more processed foods and crappy foods. And I'm sure everybody knows that, but all the EMFs in the atmosphere are changing the way our cells process energy, and that's making our glucose change too, which is not the point or topic of this video. So the normal range is changing over time, and a lot of these values are getting higher and higher and higher. So they still say normal on the blood work, but they're not optimal. They're not healthy. So that's one thing we find wrong with the blood work, or that's one downfall or caveat or critique of it. Okay. So the other thing is, back to this bell-shaped curve, 95%, 95 out of 100 samples are within this range that's highlighted here. Well, 5%, 5 out of every 100, are out here on these two little edges on the corners. These are called outliers in statistics. Well, that's maybe normal. That's probably normal for that individual, but it's not normal for the population. What's normal for the population at large is in this 95% range. But 5 out of 100 or 50 out of 1,000, these little outliers on the edges, that is their normal. So if you take your pet in when they're 8 or 10 years old and they're sick and they go to the vet, and they run some blood work and they find that some of the values are in this little 5% range or just outside of normal or just off the edge of the graph, they're going to say, oh, well, that must be the problem. And maybe it is, maybe it isn't. This is the value of getting the blood work done every year. Even though I'm talking here about the limitations of the blood work and limitations of how it's compared to unhealthy people and all that stuff, if you only have one blood work sample, you don't know if that's what's normal for your dog or if that's what's wrong with your dog right now. So you have to, dog, cat, human, whatever. So you have to get this blood work checked every year or twice a year, because 5 out of 100 dogs are going to be in that area over on the edge that's not considered normal. If yours is one of those pets and you measure it every year of his life, then when he's sick at 10 years of age and you measure it, you're going to know that that's normal for him, that the 10 prior years, his blood value was a little bit outside the range, and it still is. So that's normal for him, even though it looks abnormal on the computer printout. And therefore, you're not chasing that as his potential illness right now. You'll know that that's normal for him and his illness is something else. So this can really lead you astray if you only do the blood work once in their lifetimes, and there are 5 out of the 100 animals whose blood values are a little bit abnormal or not in the 95% range. So that's what we have there. And then next we'll talk about what each individual value means and what it means if it's out of range. But you have to keep in mind that not everybody's is perfect. These reference ranges are the average of the population. And the reference range, just that average, that doesn't mean it's optimal. That doesn't mean it's what's best. That just means it's the average of the population who, honestly is pretty unhealthy to start with. Okay? All right, thanks.